A cosmic riddle, dark and deep, where time slows down and secrets keep. Light trapped, unable to escape, as all is pulled into a cosmic scape.
What? Bro, what are you talking about, man?
Hello, everyone. Listening to these 4 lines, you must have guessed what we're talking about. If not, let's embark on a new journey. So, our today's destination is black holes. Before we start exploring these fascinating and mysterious objects, make sure to hit that subscribe button and ring the bell icon so you don't miss any future adventures. Black holes are regions in space that are so incredibly dense that their gravity pulls everything towards them, including planets, stars, and even light. Their gravitational pull is so strong that nothing can escape once it gets too close. They often form when massive stars collapse at the end of their lives. As more and more matter falls into a black hole, it grows larger and more powerful. The gravity is so intense that not even light can escape, making them appear completely black and like dark spots in space. That's why we call them black holes.
What is that?
The idea of black holes first came from Albert Einstein's general theory of relativity, which showed that mass can bend the fabric of spacetime. If enough mass is packed into a tiny space, spacetime can curve so much that a black hole is formed. It's a mind-boggling concept because we can't observe what happens inside a black hole, making them one of the universe's greatest mysteries. In the 1930s, a scientist named Supermassive figured out how massive a star needs to be to collapse into a black hole. It wasn't until the 1960s, when astronomers discovered objects like Cygnus X1, that black holes went from theory to reality. Today, black holes are among the most fascinating and mysterious objects in the universe.
Oh my God!
Oh my God!
Stephen Hawking suggested that they could slowly evaporate through a process now known as Hawking radiation. Thanks to the detection of gravitational waves and advancements in imaging, we now have solid evidence that black holes are real. They're not just science fiction, they're a genuine part of our universe. Black holes aren't all created equal. They come in different sizes and are formed in different ways. Based on that, we can classify them into 3 types. The first type is called a stellar mass black hole, which is between 3 to 10 times the mass of our sun. These are formed from the collapse of massive stars. When a star runs out of fuel at the end of its life, its core collapses under its own gravity, creating a stellar mass black hole. These are the most common type of black holes. The second type is called a supermassive black hole. These are huge, millions or even billions of times the mass of our sun. You can usually find them right at the center of galaxies. Scientists aren't entirely sure how they form, but one popular idea is that they start small and grow bigger by sucking up all the stuff around them. In fact, every big galaxy has one of these supermassive black holes at its heart. It's like the galaxy's boss, controlling everything around it. For example, our Milky Way galaxy has a supermassive black hole called Sagittarius A. It's about 4 million times heavier than our sun and keeps a tight grip on all the stars and gas nearby.
Mind-boggling, eye-popping, all new Australia's Got Talent.
The third type is called a primordial black hole. This is more of a guess than a confirmed fact. Scientists think they might have formed very early on in the universe, just a few seconds after the Big Bang. These black holes would be tiny, but they could be really heavy. They might have formed under super extreme conditions, but we're not totally sure they even exist yet. It's kind of like a cosmic mystery. The fourth type is called an intermediate mass black hole. These are kind of a middle ground, weighing between 100 and 1,000 times as much as our sun. Scientists aren't completely sure they exist yet, but there are some clues that suggest they might be out there, maybe hanging around the edges of galaxies. Now, let's talk about some of the cool things about black holes.
Yeah.
We've already touched on their super strong gravity, Hawking radiation, and how much they weigh. But there's more to them than that. Black holes have some really unique properties. The first property is the event horizon, which is like a one-way street where nothing can turn back. It's the boundary around a black hole where the gravitational pull is so strong that not even light can escape. Once something crosses that line, it's gone forever. And that's why black holes are black.
Yeah.
The next unique property is singularity. At the very center of a black hole is a point of infinite density called a singularity. Our current understanding of physics breaks down at this point. It's like trying to divide by zero. It just doesn't work. The singularity is a place where the laws of physics as we know them no longer apply. Third, we have accretion disks. Black holes have a powerful gravitational pull that attracts nearby matter. This matter forms a swirling disk around the black hole, called an accretion disk. As this material spirals inward, it heats up and emits a lot of radiation, making the disk extremely bright. This brightness is often the first clue that astronomers have when they're trying to find a black hole.
Oh, come on! You gotta admit this is cool!
While we can't see black holes directly, we can observe their effects. By studying gravitational waves and the X-rays emitted by nearby matter, scientists can detect black holes. However, it wasn't until 2019 that we got our first ever visual of a black hole. The Event Horizon Telescope captured an image of the supermassive black hole at the center of the M87 galaxy, which is about 55 million light-years away. In this image, we saw a bright ring surrounding a dark shadow. The bright ring is actually a halo of glowing gas and dust, while the dark shadow is the black hole's silhouette. This image provided the most direct evidence yet of a black hole's existence. For the first time, we were able to see the event horizon, the boundary beyond which nothing can escape. So, while black holes remain mysterious, we're making incredible strides in understanding these cosmic giants. Now, let's clear up a few misconceptions about black holes. There's a common myth that they're like cosmic vacuum cleaners, sucking up everything in their path. Not quite. Black holes mainly affect objects that are very close to them. Another popular misconception is that they're like portals to other dimensions. While that sounds cool, it's still just a theory. Black holes are truly fascinating objects that continue to baffle scientists. They don't just exist in space, they redefine the very fabric of space-time. Studying them can give us incredible insights into the origin and evolution of the universe. If you enjoyed learning about black holes, don't forget to like, comment, and share this video. We'll be exploring another cosmic mystery in our next video, so stay tuned.